Good morning, dear students. Yesterday we have discussed from the coordinate geometry the uh, equation of a line, how to find the gradient of the line, and the equation of the line in different ways. One was the basic, that was the point slope form, and then when we have given one point of the line, then how to make the equation of line, and in last, when the 2 points on the given line are given, how to frame that equation, right? So today we will discuss about the intersection of two lines. In the beginning of the chapter, when I have discussed about the pair of linear equations, pair of linear equations, there I have discussed if we have one equation as a1x plus b1y plus c1 is equal to 0. This equation is same like y is equal to mx plus c. Y is equal to mx plus c. Okay, plus minus they can be having the coefficients maybe positive, negative. In the same way, we have the second equation a2x plus b2y plus c2 is equal to 0. Now, if we have the two lines, this pair of linear equations or a linear equation, it will always represents a line. Yesterday also we have drawn some of the lines on the xy plane, Cartesian plane. We have written either y in terms of x, or we have written x in terms of y, x in terms of y. So here there is a y minus c divided by m, right? And we have made them one table in this format where the values x and y, and after plotting these points on the graph, we have drawn the equation, the lines, right? So here also we have three kind of situations. First one, when the two lines they intersect each other. Two lines they intersect each other. Second, both lines are parallel to each other, both are parallel. And the third one, that is coincide. The lines coincide. Coincide, or we can say overlap one another. Overlap, right? So in the beginning, I have discussed with you, when the two lines they are intersecting, then always we have a relation. These are intersecting at a point P. Two lines, if they are parallel, then they never meet with one another. And the third one, when one line and the another line they lie on one another, or they coincide each other. So we have discussed that. Jaswinder, very good morning, dear. So we will take some of the, in case of intersecting lines, in first case, I always we have a1 upon a2 is not equal to b1 upon b2. b1 upon b2. And in second case, we have a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, right? And the third one, always we have A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. If I have to give an example of this third one, right, coincident lines, then if one line we have like x plus another is 2y plus 6 or plus 3 is equal to 0. So line which will coincide, if I am multiplying here into 2x plus 4y plus 6 is equal to 0. These two lines, they lie on each other. If we find the solution, means the solution will be common to both the equations. Why? Because we have the ratio 1 by 2. The ratio is 1 ratio 2. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Right? So here, let me make the equation again. Some examples. First one example, if we have a 3x plus 5y is equal to minus 7, and here we have like 2x plus 4y is equal to 7. So here what is the condition? 3 upon 2 is not equal to 5 upon 4. Right? So pair of these linear equations, the pair of the linear equation, that is always consistent. The equations are consistent when they have, because the two lines, they will intersect one another and they have a unique solution. What they have, when you plot these lines, these two lines have unique solution. Unique solution. And when we have the unique solution, the pair of linear equations, they are consistent. We have, right? And here, when, like one example, we have here 2x plus 3y is equal to 10, and here we have 6x plus 9y is equal to minus of 11. So here this condition is applied. A1 upon A2 is equal to B1 upon B2, that is 1 by 3. 1 by 3 is not equal to 10 by 11. So here the line the equations, the pair of equations, they are inconsistent, and the pair of linear equations, here they have the unique solution. Here in this case, the lines are parallel to one another. When we plot the graph, lines are parallel to each other, and when the lines are parallel to each other, they have no solution. And when the pair of equations, they have no solution, then we are saying the pair of these are inconsistent. Inconsistent. And third one, already I have given one example here, like, and here these are consistent. Consistent because they have infinite many solutions. For example, if I am giving 2x plus 3y is equal to 5, and here 4x plus 6y is equal to 10. So these are consistent. So the pair of linear equations are again consistent. So in both cases, this is consistent and here also consistent. Why consistent? So we have here today Swayam also. Swayam, very warm welcome in today's class. So let's take some examples now. The parallel lines and the intersect lines, right? We have a sketch. Now we have in the question you have to sketch them, right? Question number example, that is the intersection of two lines, right? The intersection of two lines. Intersection of two lines. For example is, we have sketch the line. Question number is sketch the line. One is x plus 2y is equal to 1, and another is 2x plus 3y is equal to 4. Is equal to 4 on the same axis, and find the coordinates of point where they intersect. So here we have to plot these two lines, or we can find the solution also and we can solve. So here what is it? 1 upon 2, and here is 2 upon 3. So this is not equal to, they definitely these two lines they will intersect. That this is equation number 1. This is equation number 1, that is x plus 2y is equal to 1, and another is twice of x plus 3y is equal to 4. Right? So here what we can write, we can plot these by finding individually their points x and y, and solve. We can solve directly also. Multiplying first equation by 2, we get again 2x plus 4y is equal to 2, and subtracting this from another minus. So we have here minus of y is equal to 2. So what is y? The point of intersection y is equal to minus 2. Once y is minus 2, we can substitute the value of y in any of the equation. X plus 2 into minus 2 is equal to 1. So x is equal to 4. So point of intersection, the solution, that point is 4, 2. At this point these two lines intersect, and we can do it on graphically also, on xy plane also. On xy plane, so what is the point? Point P is the point of intersection, and we can make on xy plane also, if we want to see. This is the y-axis, x-axis, x dash, y dash. So here origin 1, 2, 3, 4, 5, 6, 7, so on, 1, 2, so on. We can name them minus 1, minus 2, minus 3, minus 4, minus 5, so on. And here 1, 2, 3, 4, 5, 6, 7, 8, so on. We can note on. Similarly, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So this is, we have xy plane. Now the first one, the graph of first one, already we have noted the solution point of intersection, that is point P, whose coordinates are. But here if we plot the first equation, x is equal to 1 minus 2y, right? We can make the solutions, right? And another is 3x, for 2x plus 3y is equal to 4. So here x is equal to 4 minus 3y divided by 2. For this we can make the solutions, right? So here first one is x, first equation is x is equal to 1 minus 2y. So here again we can, one is x, one is y. If y is 0, If y is 0, x is 1, right? And if y is 1, then x is minus 1. And if y is minus 1, y is minus 1, then x is 3. So where this line x is 1, y is 0. This is the point first. Second, x minus 1, then y 1. Here is the second point. So this way that will. And third, x is 3, y is 1. So here, and this is the equation, this is the line. And this line we can write in this way. This is the equation of line x plus 2y is equal to 1. Whereas the another line, its coordinates x is equal to 4 minus 3 by 1. If y is 0, so 4 upon 2, that is 2, right? And if y is minus 2, what is y? Y is minus 2, then minus plus. So here 6 plus 4, 10, then it is x is 5. And if y is minus 2, y is minus of 2, okay, that is, y is 2, suppose, excuse me. So here if y is 2, then minus of 1. These are the coordinates. If we plot these coordinates on the graph, first point is 2 and 0. X is 2 and y is 0. This is the point. Second point, that is 5 minus 2. X is 5, y is minus 2 here. Right? And next one is x minus 1, y2, x minus 1, and y is minus, sorry, x here is minus 1, this is minus 1, and y is 2. So this is new out here, right? So when we plot the point, but here where is the point 4 and p is 2 and x is minus 4, 2 and 4. 2, x is 2 and y 4. There is some, in this case, these two lines, they are not intersecting one, because these two lines, they are, because here one is 2x and so here point of intersection will be in a different way, right? So you can plot actually here, you have to plot these on the grid, on the graph, and the graph accurate value you will find, right? So let's take one more question that is based on find the coordinates and vertices of triangle whose sides have the equations. Now triangle is given. Example is 13.13, sorry 3.13. Example, that is 3.13. It says that find the coordinates of the coordinates of the vertices of vertices of the triangle whose sides have equations, whose sides have the equation, x plus y is equal to 4, x plus y is equal to 4, 2x minus y is equal to 8, 2x minus y is equal to 8, and the last is x plus 2y is equal to minus 1, right? So here we can find the solutions. Here in another way, they have formed directly the points, right? They have solved on the grid plane. So we can choose first two. One is x plus y is equal to 4, and another is 2x minus y is equal to 8, right? So here the points of intersection, when we add both, we have y cancel, 3x is equal to 12, so 1 is x is equal to 12 by 3, so it is 3 ones are 3, 3 fours are 12. So what is the value of x? The value of x, that is 4, right? And putting the value of x as 4, so 4 plus y is equal to 4, so y is equal to 0. So what are the coordinates of a point? Point A is having coordinates that is x is 4, y is 0, right? And the second equation, one with 2x minus y is equal to 8, and x plus 2y is equal to x plus 2y. Here we can write that A points the vertices, that is 4 0, right? And here, that is for second vertex, 2x minus y is equal to 8, and here x minus 2y is equal to minus 1. Now here we can multiply the first equation, this equation with the 2. So here we get 4x minus of 2y is equal to 16, right? And we can subtract this equation. This is minus, this is plus, minus. So here we will get cancelled, and we have 3x minus of 3x is equal to minus of 17. What is the point? Minus of 17. One is 2x minus y is equal to 8, and another is x. Sorry, it is x, it is plus here. This minus take here, it is plus. This is plus. So we can multiply. Here we can add only for the first equation. This 2y is equal to minus 1. So this is already. So here we can multiply the second equation also. We can resolve x. Here we can multiply second also, second by 2. That is x plus 2y. So what we will get? We will get here one is 2x plus 2y. So it will become 4y. It will become 4y is equal to minus of 2. And first equation is 2x minus y is equal to 8 minus plus minus. So here we have 5x, 5y is equal to minus 10. 5 under 5, 2. Y is equal to minus 2. If y is minus 2, what is x? substitute the value of any equation. That is 2x minus of minus 2 is equal to 8. So here again 2x is equal to 8 minus 2, 6, and x is equal to 3. So the coordinates of this point, B point coordinates, x is 3, y is minus 2. What is it? X is 3 and y is 2. So last point of the triangle, 3, these lines are given. Last one is x plus y is equal to 4 and x plus 2y is equal to minus 1. First and third. Right? So here we can subtract one from another, minus, 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 plus, cancel. We have here that is y minus of y is equal to 5. So y is equal to, in this case, y is equal to minus 5, and substituting the value of the equation, that x minus 5 is equal to 4, so x is equal to 9. So the point C is having what is this 9 comma minus of 5, right? So if I have to plot the triangle, if on the grid plane, so roughly here, if I have to plot the points ABC triangle, ABC, A is having coordinates 4, comma 0, B, the coordinates, they are 3 and minus 2, and C coordinates, that is having coordinates 9, comma minus 5. These are the solutions. We have few more, one or more questions. Let's take these questions. Example, next example is, so here we have 4, 0, B is 3 minus 2, very right, and 9 minus 5, 9 minus 5, very right. So here we have the equation, L has the equations and M has the equation. What can you say about the intersection of these two lines? Next question is given. It's not example, it's this question. Question is, in this question, the line L has the equation, the line L, L has equation 2x minus y is equal to 4, and the line M has equation y is equal to 2x minus 3. What can you say about the, what can you say about the, what can you say about the, say about the intersection of, about the intersection of these two lines, what can we say about the intersection of these two lines, right? Intersection of these two lines. So here one line, even the rough we can discuss here, its rate coefficient is 2 and one's coefficient, that is also 2. But we can rearrange them in the same way. One is 2x minus y is equal to 4, and here it is minus of 2x plus y is equal to minus 3. So here 2 upon minus 2, this is 2 upon minus 2 is equal to, what is equal to? This is equal to minus 1 upon 1 is equal to, is not equal to 4 upon minus 3. So here these two lines are confirmed parallel lines. These two lines are confirmed parallel lines. We can plot these points. We can check also here. If adding, this is equation number 1, this is equation number 2, adding 1 and 2. Adding 1 and 2, what we will have? That is 0x. So here this will get cancelled. This is also get cancelled. What we have? 0 is equal to minus, sorry, 0 is equal to 1. So this is not, this is 1 cannot be equal to 0. Right? So here this implies that the pair of linear equations, the equations line L, the line L and line L and line M, they are parallel to each other. Are parallel to each other. This is the condition. Right. This is A1 upon A2. What is the condition here? A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, where A1 is the coefficient of x and B1 is the coefficient of y and C1. So here these lines are parallel to each other, right? So in the same way, we have so many questions in the exercise, that is exercise 3D. Like first question is, find the vertices of triangle ABC. Same question we have discussed. Exercise 3D. So in exercise 3D, question number 1. Here the questions are given. We have to find the vertices of triangle ABC. Vertices, find vertices of triangle A, B, and C. Right? If AB, one triangle is given, the AB triangle, AB side line that is given x minus 2y, such that xy minus 1, BC, that is 7x plus 6y is equal to 53, and AC is, what is it? AC here, AC that is given 9x plus 2y is equal to 11, right? First is, that is equal to minus 1 here, x minus 2y is equal to minus 1, 7x plus 7y is equal to 53, and 9x plus 2y is equal to 11, right? So how to do it? When these two lines, one is AB and one is BC, one is goes AB, one side is your AB and another side is BC. So we will get the vertices of B, right? One here, one is your x minus 2y is equal to 1, and here it is 7x minus of 6y So not minus x plus of 6y is equal to 53. So here this will give the coordinates of point B. Right? Second, when we have BC, one is BC and one is AC. It will provide what is the point C. Right? These two lines. And the third one is AB and AB and AC. AB and AC. This x minus 2y is equal to minus 1. 9x plus 2y is equal to 11. It will provide the point C. Right? This will provide the point B here. So here, first one, this is B. This provide the point C. 7x plus 6y is equal to 53. 9x plus 2y is equal to 11. Right? So in this way we will find all the three vertices. So first one, we can multiply first equation by 3. When we multiply first equation by 3, we will get 3x and here minus of 6y is equal to minus of 3. When we add both equations, we have 10x and here cancel and here is equal to 50. So what is x? X is equal to 5. If x is 5, what is y? If x is 5, 7, or we can take the smaller one also, any of the equation we can put. 5 minus 2y is equal to minus 1. So here 2y is equal to 5 plus 1. So y is equal to 6 upon 2 is equal to 3. Right? So what are the coordinates? Y is equal to 3 and the coordinates of point B, triangle ABC, B are 5, 3. Now next, in this equation, equation number 2 and 3, this is BC and this is AC. So here we provide a point C. So here one is, this is the 6, here is 2, multiply this equation by 3. What we will get? First equation is same, that is 7x plus 6y is equal to 53. Here 9 3s are 27x and plus 6y is equal to 30. Now when I subtract the equation from the sign are changed. Here when we subtract, we have minus of 20x. Here get cancelled and here we have 20. So what is x? X is equal to minus of 1. And substituting the value in any of the equation, but x is minus 1, so 9 minus 1 plus 2y is equal to 11. So what is 2y? 2y is equal to 11 plus 9, that is 20, and 2 get cancelled, y is equal to 10. What is y? Y is equal to 10. So point C, the coordinates of point C are A coordinates, that is, let me write here, C coordinates, x is minus 1 and y that is 10. Now the last, in the same way, the last equation, these two equations, 2y, 2y simply will add and subtract. When we add this 10x, here get cancelled and we have here 10. So 10 with 10 cancels, the value of x here, that is 1, and substituting the value 1 minus 2y is equal to minus 1. So 2y is equal to 2. So y is equal to 1. So the point A, What is the coordinates of point A? A point's coordinates are 1 and 1. What are the points B, C, B points, that is 5 and 3. These are the, from these three given lines we have, right? So dear students, you can try these. Now in the examination, the examiner is also interested in their sketching. You have to sketch these lines on the graph. Okay, and this, so many questions are there in exercise, so you can do it, right? And this is sufficient for today, right? So please go through these kind of questions where I have discussed today three things. One, when the both lines they intersect each other. When the both lines they intersect each other, that point of intersection is the always unique point, and the pair of the equations they are said to be consistent. The pair of equations they are said to be consistent, and they have unique solution. And what is the condition? That is a1 upon a2 is not equal to b1 upon b2. That a1 upon a2 is not equal to b1 upon b2, right? So the next, when we have the parallel lines are parallel to each other, when a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, right? And when the two lines they superimpose upon each other, they coincide with one another, then we are saying the pair of the equations they have infinite many solutions. In that case also we are saying the equations are consistent. So when we are saying the equations are consistent and when the equations are inconsistent, consistent when they have a unique solution or infinite many solutions, then the pair of the equations are said to be consistent. And when the two lines they are parallel to each other, if the two lines they are parallel to each other means they will not meet with one another, so they have no solution. And when the pair of equations they are parallel, we are naming them as inconsistent. The pair of equations they are inconsistent, right? So this is all about today, right? Tomorrow again we have the class at 12:10. Okay, fourth lesson we have. So we will tomorrow complete the remaining part of the chapter, right? And then I have discussed yesterday. Next we will start chapter 4, that is the sequence and the series. So with this I am ending today's class. Thank you very much. God bless you all. Stay safe and stay healthy.